I'll just do a quick lecture on the recommended readings for this week. And really, I'll just be talking about the Elhorst reading. So he summarizes some of the most important contributions from the textbook. I don't expect you to read the entire textbook. It has some great information. I've read when I was trying to, to first learn spatial stuff on my own, the first two or three chapters at different times, but I don't expect you to read a full textbook in 1 week. But it is there if you need it. It does have some great information. If you need more detailed help later as you're going through working on like a homework assignment or a project, or maybe after this class working on your thesis or whatever, it can be really useful for that. So I do want you to have access to it. But it's not necessary for what we do this week. Now, the big takeaway from Elhorst and from the textbook too is that if you're doing applied work, you need to be using the right models and interpreting it properly. So for one, the spatial Durbin model should be your default. That's kind of one of the big lessons of this week is that's like your sort of null hypothesis. You start with the spatial Durbin, and then if there are other characteristics of the data that suggest to use the SAR or the SEM, then you go with one of those. But only use those other models if you have a reason to. Now, the LM test can help give you a reason, but it should be if you're unsure between like the spatial Durbin and the SAR. Like it shouldn't be, you shouldn't go in blind and just follow what the LM test says. I know in the past, I've read some articles, and at least in one of mine, I've probably gone a little bit too strong with just taking the LM test as my justification for choosing my model instead of using some theory to ground it in. Although I ended up opting with the model that I think theory would have backed up. But this is really, really important, and it's kind of like a mindset thing. So it's sort of when you're thinking of step one, step two, step three, you're kind of like a checklist while you're doing your empirical analysis. This is kind of setting up that checklist. So this week we'll be working with spatial data again in the homework, kind of getting our hands dirty. This time, instead of identifying spatial autocorrelation, it's going to be using these models for data with some spatial relationships. So Elhorst provides and summarizes the modern standards of good practice. So you don't choose the SAR or the SEM by LM test alone. You need some theory to suggest that. You can use the LM test to back it up, but it's theory first. And don't interpret the coefficients. We talked about that a lot this week. This used to be a really big problem. And I've gotten some questions when I presented some spatial stuff in the past at conferences where they're like, why are you skipping over the coefficients? And say, no, you interpret the direct and indirect effects. This is the actual estimation that we care about. He also says to don't treat the W matrix as arbitrary. It also needs to involve theory to set up why you choose the W that you choose. And again, like a lot of the readings this week, he says, don't start with the restricted model, meaning the SAR or the SEM, or maybe some of the other ones. Start with the spatial Durbin and then test down to see if there is only spatial autocorrelation in the error term or in the dependent variable here or there.